Okay. All right. So today, let's continue on from last week and talk about shell and then into shell scripting. First thing first, I want to talk to you about this technique that you can use to go log into the server and then use public key cryptography to avoid having to type in the password all the time. So the way it works is like this. So let's say you are communicating between the server and yourself, right? From A and B. In cryptography, they'll usually use Alice and Bob for A and B to be more clear about who are you talking about and what's the entity. All right. So what happened is, one thing I do is I can generate the key. And the way public key cryptography works is gonna revolve around this concept of public key and the private key. All right. So the way I can generate this key, we can use multiple techniques that allow you to generate a public key, which is a key that everyone will have access to, and the private key, which is your own key that you're gonna give to anyone. That's a key that you store just in your computer, not anywhere else. All right. Then, when I want to encrypt something, for example, Bob wants to send an encrypted message. Hello, Alice. You can take Alice public key. So basically, right now, Bob wants to send a message here. Basically what I have to do is to take Alice key, encrypt the message with Alice key. This becomes the encrypted messages, which you can establish between the server and your computer. Now you can send the message over to Alice. And then Alice, once you receive the message, you can use the private key. Basically, the combination of the public key and the private key, there are math operations that guarantee that if you do this math operation, you will get the original message. And the whole point of this is the amount of computation, the amount of CPU time that you have to spend to crack this is going to be exponentially high, to the point that you're gonna take maybe 100 years to crack it. So that's basically the key idea behind this. The idea is I cannot brute force. I cannot try every single operation to see the private messages. And this allows you to talk to the server. For example, when you have a server, one thing you can do is you can use SSH, which is what we call Syskill shell. Syskill shell is basically a shell that allows you to establish a secure connection between your laptop and the server. And when you have this connection, right, you can then send your public key to the server. Now the server have your public key, which means that communication between your computer and the server can be done encrypted, and the server knows how to decrypt it, which means you don't have to use any password anymore. And the way you would do this is to use a program called SSH, which is the program you can use to connect to the server. There's a specific program called SSH keygen, will generate the public key and the private key. You keep the private key. Then you put the public key on the server inside this directory, inside your home directory. There'll be a directory called .ssh. That's where any configuration that has to be is going to be stored. You open the file called authorized key. These are any key that you would authorize to use the server. You put your key in there. Then afterward, you don't have to use your password anymore to log in. Now the server knows you, and you know that you can trust whatever is coming from the server. And this allows the secure connection between the two entities.
So is this how the universal password system?
Not exactly. So remember password system, like say on Google Chrome, right? those things would store encrypted password on Google server, but then you can use those encrypted password on your own. So basically, those techniques, everything is yours, right? You can access your own data, and Google will provide security enough to guarantee that, hey, unless Google server is hacked, which, to be honest, will likely be the apocalypse of the internet as you know it, right? But if you can trust Google in maintaining your password, then you can use this encrypted information to restore your actual password.
What about the like the Wi-Fi?
The Wi-Fi on the phone is something, so basically when you connect to the Wi-Fi, right, you store the key, basically the Wi-Fi security key to connect to the Wi-Fi, and afterward, usually those information is now stored on your phone. So the next time you connect to the Wi-Fi, the phone actually basically use the old information. If the difference is here, you don't need password at all. You now can go in. If the server password for your account is changed, you can still go in. For your Wi-Fi, if the Wi-Fi password is changed, now you have to update. So that's the difference. So the mechanism around this whole thing is different. This one is to encrypt the messages between your computer and the server. So to do this, you can use SSH keygen, which is available on your computer. Once you install SSH client, usually if you have a computer, it's already installed. In the fresh Linux installation, you might have to download SSH first. Then you can do SSH-keygen with the RSA. Like over here, -t RSA will use the RSA encryption, which is basically it's encryption that is used everywhere nowadays with certain base that would allow you to basically generate a really long string of random letters and character and number, which becomes your key. Then you basically copy that file, which is your public key, to the server, and that's it. This semester we don't have the server for you guys right now. We still again need to figure out the server situation. That would take a while. So once we have that, I do recommend you to try. This is basically one of the options that I was thinking that if you want to use the server, I would disable password, and everyone needs to use this. It will be a lot more secure than a password. Why is it a lot more secure? Only your account will have the access to put the public key on the server, and if it doesn't match, no one can go in. Basically, if you switch a computer, you cannot go in, which also means that I will have to manage that for you guys somehow. So that's why I said we have to figure out, because that's a lot of overhead. Because how many machines are you connecting from? Like laptop or desktop at home, right? So it can be a bunch of them. Now, let's go back to the topic that we left last week, right? The path variable. So we left with a question that say, hey, when I type in the command like ls, how does it find the command? So this is what happened. Your shell has a special variable. So in computer science, what do we use variable for? Yeah, to store things, right? So you would use this path variable to store things. Quick thing, if you want to talk, can you talk outside? Guys, yo, if you want to talk, can you talk outside? Thank you. So the path variable, we can use this to store any information that we want to use to search for the command, right? And your shell will have many variables tied to the shell, and path is one of them. And as the name suggests, that has to do with the location. There can be many other things that are stored on your shell. For example, there can be a variable that contains the path, not for the command, but for any install libraries or APIs, right? when you install, for example, Python for the first time, it will also modify some of these variables. So now it knows any internal information required by Python to start the actual Python interpreter so they can use it. Path is one of these, what we call environment variable. It's the variable that becomes the environment of your shell. Again, shell is what you use to feed in the command, right? And to run any command, you need to know what are any configuration per se, right? Configuration tied to the command. Path is one of them. ls, for example, is stored in /bin/ls, which means that in this case, right? In this case, my path has to store /bin. Because otherwise, when I type in ls, it doesn't know where it is. It needs to make sure it's stored at least /bin. So it first will search that directory. It's like, oh, okay, ls is here. Let me run this command. And to check where the command is, you can do which followed by the command name. So let me open up Windows System for Linux. All right. So I guess as usual, I'll turn off the light so you can see the screen. Oh, right. If I do which ls, it will show me that okay, it's in /user/bin/ls. I can do this for any command, like C compiler. We will use this to compile a C program. So now it's actually now stored in /user/bin/gcc, right? So it means that the path, yes. Sorry. Okay, why not using the command find to find where the command is, right? You mean comparing to the which command or okay, yes, great. So the find will find any file with the name. The which command allow you to basically whatever command sound like cp, it will allow you to print if I were to type cp right now, what file are run. So it identifies the actual file that are being run right now as well. So let's say there's like 3 different versions of GCC everywhere in your computer, right? The find command will print the 3 locations, but the which command will tell you that that's the location you actually run. The other 2 is not the one you're running. So there's like a subtle difference. But yeah, that's a great question. It's for the, yes, exactly, yes. It's for the current environment that you're running your shell on. Yeah, perfect. You can modify the path by using the export command, for example, something like this, right? Export path equal $ in front of anything will print the value. Basically, it will use the old value of the path and then add /home/rashada/bin to that. All right. And let's say here is your path variable, right? Right now, how many directories is your path variable pointing? How many? Again, it's divided with with colon, right? So that 3 chunks here, /user/bin/bin and /user/sbin. What will happen is if you run any command, let's say I run something like this. Sorry, semicolon will separate the command. So let me type some nonsensical command. This thing doesn't exist. What will happen is it will search that command from your path directory one by one. So let's say this is my path directory, right? It will first go into /user/bin, search for that command. It will not find any. then it move on to the next part, then move on to the next part, and you cannot find it. It will say command not found. If you can find the command, it will use that command. Then to check what is your path variable, you can use the echo command for that. It basically, think of echo as print function in Python. Same thing, right? Echo hi will print hi. I can do this. Echo hello, which will basically print hello, right? I can also print something like the path variable. So over here, because it's Windows subsystem for Linux, it also have multiple Windows-based path as well. So it's a little bit more annoying to look right now because it contains multiple directories, right? But you can see that there's like /hbin, /sbin, /bin, /user, /game, /user, local bin, and many other locations here, right? So I can use the echo command to print out the content of the path variable. Any question over the path variable before we move on to process management? All right, how many of you write Python? Did we cover recursion in basic programming? All right, how many of you write a recursion code that doesn't finish by accident? Awesome. So what do you do afterward? To stop. Hit stop, right? So imagine this. Let's say you're on a terminal instead of using your IDE, right? Using IntelliJ or something to run Python. I run my program and it doesn't stop. What can I do? I can close Windows subsystem for Linux. So for sure, that would kill the process. All right. What else can I do? So let me build a function that doesn't stop, right? Basically infinite loop. So Syskill, oops. All right. So what you can see here is the function. In C, the main function is when you start the program, that's the function you run. What I do here, while one. I don't do anything but keep going into that loop and never stop. All right. We will go over more detail on how to write code in C. Basically, the gist of it is this program will not stop. So I'm basically running this program right now. It's running. It doesn't give me any prompt. It means that program is running and it doesn't stop. Great question. So let me first stop it, right? I can do Control C to stop. This will kill the process. All right, Control C will kill the process. Now, I can run this in the background by using ampersand at the end. If I hit enter, this process with the number 175, that's the process ID, get run. I can use the command top. Top will show any running process, right? Remember 175, that program I just run. See how it used 100% CPU right now by running an empty loop with nothing while one just keep running. See, right? So you can see that this is interactive program. You see how time keep counting up, like top 12:29:49. That's the current time right now, right? It updates I think every 3 seconds. And you can see that this process ID 175 doesn't stop. It keeps running. It is running basically. How do I stop this? One thing I can do is to use the Q command. I use the Q command. Now I'll do top again. All right. See how 175 is gone. All right, how 175 is gone. To go out of this, I can also kill top by doing Control C. So I'm about to type Control C, Charlie, Control C. It will stop. And it basically prints the status that, hey, I terminate that infinite loop program. All right. You see how this is allow you to control the process without closing the shell. I can have shell running. I can run something in the background that you saw earlier, and I kill something. All right. So again, process is a running instance of the program. It runs under certain environment. All right. Each process has a unique process ID. It's a number. Basically, why do we need this? Why do we need a process ID? Yeah, let's say you open Google Chrome, right? Let's do Task Manager. I'm pretty sure there's a lot of Google Chrome here. Wait, give me some, wait, what? I cannot click. Moving. Here, see? Because I have WebEx and everything up, right? It actually spawned many services under Google Chrome. But now I can edit. Sorry about this thing keep moving because that's Task Manager. I think I store it by something. I actually forgot what I stored it by, but you can see that there's a bunch of these, right? It allows better management. I mean, you can say Chrome, that works as well, right? And you can be a process called Chrome. But let's say that 5 of those, now you might need a separate ID because you have 3 or 5 Google Chrome opening up, right? You might want to close the second one and mark the rest. All right. These are, think of it as just a number. And in reality, the computer just manages it with a number. Why is number good? Why is number more convenient than a text? Why they keep track of the process using a number rather than Chrome as a text, as a string? Huh? Faster to type. Also, more space efficient, right? A number is like 4 bytes. If I have a like Microsoft Word, how many letters is that? It's gonna take more. Also easy to keep track of everything because if you give unique ID to everyone, you guarantee uniqueness. If I refer to a number, I know it's that program for sure. It's only one-to-one mapping. Then on top of your own process ID, you have to keep track of who spawned the process. How many of you play games on Steam? Okay, good. Everyone. You realize, right, when you have Steam opening up and when you launch a game, Steam launch another game, right? You might have to build the connection. I have Steam and have my own game. You can think of those analogy as Steam is the parent that spawned the process that is your game. All right. So when you have a process ID, you also have the ID of your parent, so you know who started this process. Then you have the user and the group number that will tell you what user run this process, and the priority tied to the process. The priority is to make sure that if I have, say, how many CPU core do you have on your machine? 3, 8. Okay, let's say you have 8 cores, right? How many programs you are running right now on Task Manager? Is it more than 8? You can go to Task Manager. So basically, for every single computer, you're basically running many programs at once, right? But you have only 8 CPU cores. So any given time, only 8 programs can run. What happens? So the question is, what happens? We have, say, 10 programs that you want to run, right? So let me ask you this question first. As a user, do you experience that all my 10 programs, like something is stopping, or does it look like everything run at the same time? Do you ever realize that your 15 programs you have open actually take turn using the CPU? So basically the idea is each program when you run becomes a process. Each process will take turn using the CPU. And the job of the system is to make sure that you as a user did not recognize that at all. You think that, hey, all these 15 programs run at the same time. Perfect, in a perfect world. All right. So that's a really good system building. I want to be able to build the OS, Linux, Windows, Mac OS to make sure that I can run as many programs and user doesn't notice anything. All right. But that also means that you need to know the priority, right? So let's say you print something from your PDF. Do you care at all about how fast the packet from your computer is sent to the printer? Is it okay if I delay it by 2 seconds? If I want to print something, is it okay if I delay that printing by 2 seconds? Do you care? Probably don't, right? You probably didn't even realize that it gets delayed, but they have low priority. You don't care. How about your game? What if I say I'm going to delay everything? Like you click a mouse, I'll delay that by 2 seconds. You probably will stop playing that game, right? So each process has its own priority tagged to the process itself. All right. And the OS, the operating system, would use that information to figure out who gets to use the CPU, who gets to use the CPU more often. All right. Under management, you just saw already the top command is the command called TOP, top. Will you guys use Task Manager on Windows 4, right? Same thing, but for Linux. It tells you CPU usage, memory usage, the process ID, the name, and who run the process, who's the owner of that process, what username, what's the. Then there's a PS command. The PS, unlike top is interactive. As you can see here, right? I keep it open, and this is interactive. You'll see things updated, right? The PS command will not be interactive. You type in, that's it. Right now, as you can see here, right, I'm not running anything. So as you can see, it's only bash, which is the shell command. Bash is the name of my shell. And PS is the command itself, right? So that's the only two things that are printed. Q, you saw it already when I have an infinite loop program. So let me do it again, right? I have a program called a.out. That's the C program that doesn't do anything except going into the loop and never exit. I run this in the background, and let me run it multiple times. Right? Okay. There are 5 processes. All of them are just in the while loop, doing nothing. It doesn't stop. All right. They're all running, as you can see here, or that's the status, or it's running, else is stop. All right. I can also do PS. As you can see here, it will give you the process ID. Okay. That's the terminal that you're running from, which is basically right now this terminal. The time that's been running, and the command name, the name of the command a.out. Basically, if I don't specify the output file name, the compiler for C would basically use the default name a.out. It's a program called a.out. That's it. Q will allow me to send the signal called Syskill into this OS and say Q that process. So I can do Q180. What would happen if we do this? I hit enter. Let's list the process again. 180 is gone, right? So to kill this all, I can do Q181, 182. One more thing you notice, the message here, when I send the Syskill, when I do kill something, that's it. stop immediately or does it spend some time? Yeah, I mean, when I do kill 182, right? 182 is like get killed almost immediately. You saw that. And then for 183, it takes like 2 seconds, if I remember correctly. So when you send the kill command, these are buffer up. These are basically weight up in the line. Say, hey, I'm going to kill this. The OS will take in this command and finish them. Some of them will be quicker, some of them will be slower, depending on the status of your machine at that point. But eventually, they'll all die. Basically, the process will be terminated. All right, so that's the kill command. The jobs command will list the current jobs that run in the background, which right now I don't have anything, but I kill everything, right? Let's run something again. All right, I run the infinite loop program again in the process ID 188 and 189. You see how the two things are running? Actually, there's one more thing that I think got killed earlier. All right. You see how this is only showing the background job, not the foreground. It's showing just the background job. Okay. If I do PS, again, because the Syskill doesn't handle the last queue until now. So let me do PS again. That's 188 and 189, right? Those are the two programs I run. If I do jobs again, that's 188 and 189. The two running programs. All right. Notice how the PS command show bash and PS. These are the foreground jobs. What does foreground mean? It's something in the front, right? It's basically your interactive program that you're running right now. Things that you're running in the background, and as the name suggests, you run that, it gets sent to the background, see if you handle that. But as a user, I don't even recognize that a.out is running. All right. FG move a background process into the foreground. Control C will pause the current foreground process and move to the background. So let's try that. All right. Right now, nothing is running. Again, let's clear it up. Let me clear this screen, right? I'm not running anything. So let me run a.out. Infinite loop. If I do Control C, zebra, now a.out will be in the background and it will stop. So Control C will stop and then put that in the background. I can do FG. Yeah. So now job number 1 is stopped, right? So I can do foreground 1. Now it resume into the foreground. See how I can't do anything with my terminal again. Now it's running in the foreground. I can move them back to the background again. And I can move them back to the foreground again. All right. Now let me kill it. So now it's gone. Here is one really common use of PS command. All right. PS AUX. AUX are the 3 options that I can put in. A, show the process for all the user. U will display the username. X will also show process not attached to the terminal. What does it mean by that? These are the process that, let's say I connect to the server, I'm done. I disconnect. But let's say there's some process still running. Let's say there's some process still running. I might want to identify this kind of process where no one is using, but by accident, they're still running on a server. I do the option A and U to make sure I show every user processes so I can maybe kill them afterward. For example, if I do this, it might show a bunch of usernames here, right? Root, systemd, network. There's many services that are running right now. And in this case, these are not attached to a terminal, means that no active user are running this right now. But these are safe because these are running the system, right? Like things like network service and all those things. Usually these are like run by the system. That's why there's no user attached. There's some. How many of you use VS Code? Yeah. So there's like previous semester. Can you wear your mask? Thank you. Previous years, there was many instances that the student used VS Code on the server, and when they're done, they forgot to disconnect. So there's like a lot of what we call zombie VS Code process. It's running on a server, spawn VS Code, but it doesn't stop, and it slows the server down quite a lot. So what I do is I will periodically go in and kill them. The queue basically will ultimately send what we call the Syskill command. It's a command sent by the hardware telling the process to terminate. It takes the process ID, in the case Q12345 will kill the process with this ID. It's really useful to, for example, I have an infinite loop. I can send a Syskill onto this process ID. I can have zombie processes as well. Let's say I spawn a lot of programs into processes. I run a bunch of things, and I have the server on for like 1 month already. There might be a chance where some of these programs doesn't exit normally. There's like some bug or something wrong with the hardware that caused the program to terminate. But inside the program, it launched more processes. Those new processes might not be terminated along with the parent. So in that case, it becomes a zombie. So in that case, I might have to go in and clean those as well using the kill command. There's more useful command that we actually use quite a lot. wget download a file from the internet. wget with the address will give you a method to download the file into where you are right now. Zip, unzip will compress, decompress, or will pack multiple files into a single file. You can also add the option to compress them along the way as well. So it's an HTTP client, which means that if you have the curl command, you can then basically browse the internet. You can curl for HTTP client, basically not get the link, but go there to get the content of the server, then process the content afterwards. Head display the first n lines, tail display the last n lines. Somehow you don't want to print the whole thing. I maybe want to just go access the first 50 lines. I can do head with the number of lines 50, will print the first 50 lines. The up and down arrow, I basically hit up and down right now. It allows me to rotate the history of the command I type in. Tab will autocomplete for me. I do recommend you to try like type the command, hit tab without finishing everything. It will auto finish the path, for example, for you. Control C will stop the print program. Control R will allow you to search the command history. So let's try this. Right here, foreground, right? Sorry, I typed FG and it basically show the history of my command tie with FG. Control L will clear the screen. See? I just hit Control L, which will clear the screen. Now that's it. Any questions so far? Before I continue on with like, what if you have a file like Python, but let's say many users, like let's say you use a server and your first assignment is install Python on the server at your home directory. In that case, every one of the students here, every one of your home directory will have Python in it, right? Which one to use? How can you tell, right? Because they'll all name Python, but there'll be Python in the different places, right? What if you have, for example, the ls command, but it's the ls command at 3 different places, right? There are 2 ways you can do this. First, you can, if you know exactly what ls command or what Python command you want to run, you can give them the full path /home/rashada/bin/python will run, for example, the Python command inside my home directory /bin. Otherwise, when you type in Python, in that case, you go with the default. Why do we need this? For example, I have an experiment for my PhD project that required GCC is a C compiler. I need GCC version 4.4 for the main program. Then I need GCC 5.4 or more to run the application. So the main program fake a GPU, but you can run a real GPU program on this fake GPU. But I need version 4.4 for the main program. I need version 5.4 to run the application, the GPU program on this thing, which means what? I need 2 versions of GCC at the same time to build this whole thing, right? This is similar to, let's say you have a script that needs Python 2 and Python 3. Some file need Python 2, some file need Python version 3. So in that case, you need to install both versions in the computer. This means that I need to make sure the GCC command that needs 4.4 point to the correct version, and the GCC command which has the version 5.4 also point to the correct version. And you can, that's the multiple things you do. You can specify the full path to the 4.4 and the 5.4 version. You can change the path variable whenever you need 5.4 so that the path variable point at one place. If you need 4.4, it point at another place. So there are multiple ways you can do and go around this. An executable means a program that can be run. So when you use the shell, you can run either a valid program, a valid binary file. These are valid programs that you can run, or a script, which we are about to go into now. All right. Obviously, you can run any program, but now it can also run a script. Think of a script. For example, a bash script is a bunch of your shell command that you put in, but instead of running one command at a time and keep typing, you write that into a file, and when you run that file, every single line is run all together, right? And to do this, right, you can write a file, and then on the top of the file, I mean, Python is also a scripting language, right? You can write one line at a time in Python, and the program will run one line at a time. All right. So to write a script, the first thing you have to tell the computer is, what are you using to run this script? Is it a bash? Is it a Python, right? So you can use this thing called shebang, which is pound exclamation mark followed by the path to the interpreter for your script. For example, a shell script, use either bash or C shell. If you use MacBook, it's going to be /bin/csh. You basically tell the computer, use that to run every line in here. If your script is a Python script, then you do /user/bin/python to tell the computer, say, hey, instead of treating every line here as a shell script, that's a Python code, so use a Python interpreter to run this. Then you need to use chmod to add the executable flag. Don't forget to do this so that you can run. Remember, read permission, write permission, and execute permission. Use chmod +X would add the execute permission on the file. All right. So before we transition into shell scripting, let's maybe do 10 minutes break. We'll come back after the break with some demo and basically some more instruction on how you can write your first shell script. All right. So yeah, so let's take a quick break now. What's the plan? How do we archive our home directory? So what are the steps? Maybe like zip or tar them, basically combine them into one single file, right? But if you combine to a single file, you want to write a script, and every time you run a script, one of the problem is every time you run, you get the same output file, because you might want your output file to be like home directory name, date, and time, right? To make sure you know, okay, this zip file is a snapshot of my home directory on Tuesday or on May 2nd or May 3rd, right? That would allow you to identify what version is this home directory. So step 0, maybe get the date. You'll see that in a bit. So basically that's another slide for this. But I just want to establish some steps in your mind right now. So these are the things that I might have to do. So make sure the date and time is part of your file name, right? Third step, move to /temp. Basically, once you're done, move the file over to temp. So now you have to back up. That's it, right? So that's the overall strategy, right? And you can write these as a series of commands, right? Here's one example of like a pretty useless shell script, right? One thing I do first, tell the computer, if I were to run this file should be run using the bash as an interpreter. Now, it would invoke the bash on all the commands you see afterward. Basically, tell the computer that for every single command here, use bash to run these. Right? It's as simple as that. Shebang tells the computer what program do I run these command with. And in this case, bash. Okay. What it does here is echo hello into test.text and then copy that to text.test and then you print it out and remove it as you said. As I said earlier, a pretty useless script. So let's go with something more useful, which is, for example, archiving your home directory, right? But before we go there, to be able to archive, right, you would first need to find the date and the time, and you have to store them somewhere. We can use a variable, right? How many you guys are familiar with the concept of variable in Python, right? Works the same way. Name restriction don't well, you can only have letters, number, and underscore for your name. So here I can have a script that when I run will print welcome back followed by username. Today is followed by the date of the day, like today, for example, Tuesday, right, which is the best day of the entire week. First line is shebang bin bash, making sure that the whole thing is run using bash shell, right? This is a variable. So everything to the left of the equal sign is a variable. The equal sign is an operator that stores whatever is to the right into the left. So I store the text welcome to greetings. The next line is, this is a command. If I type in who am I, print the username. the command who am I will give me the username of whoever is logging in right now. All right. So that's the text. I want to parameterize into a variable. I put parentheses over the command and I put $sign. This would make sure that this whole thing is treated as a variable and I assign that to the user. The next command is date. So I can do date plus %a. Date plus %a. To print, so the plus %a is an option that instead of, for example, print out Tuesday, May 2nd, like this long date. This will just give you Tuesday. That's it. It's an option. You can use the manual to check out what are the possible options, right? We are not going to go into the detail because there's a lot of this. So I do date plus %a, just print Tuesday, parameterize into a variable, store that in the variable called date. Now I have 3 variables, right? Greeting. I have user. I have date. So these are my variables. How do I use it afterwards? Echo, right? You see echo in the quotation mark is a string that you want to print out. So echo, if it's a variable, you put $sign in front. So if you want to print the value inside the variable greeting, $sign greeting. So over here, instead of printing $sign greeting, it will actually print Prashada. Oh, my bad. Greeting is welcome, right? First line. Greeting inside them is just a word welcome. So welcome back, and then user in this case, for example, if it's my username is welcome back, Rashada. Today is Tuesday, which is the best day of the entire week. That's possible. Then you can also print an environment variable. See it down there, right? I never define bash version. But if I do this echo $bash version, it's one of the environment variables that tells you what version of bash that you're using right now. All right. So your bash shell version is over in Visual like 5.2. Basically, that will get printed. Enjoy. That's it. I can write a script this way. Now, one more example. This is where we talk about when you want to archive your home directory. All right. So the first thing is, if I want to archive my home directory, I need to make sure I know where is that home directory. It's going to be in /home. For example, this is mine. It's going to be /home/Rashada, right? So the first thing I need to figure this out, my username. So I use the who am I command to figure out home directory's location. Because it's going to depend on the username. All right. So the input will be /home/$user, which in this case is /home/Rashada. Output file will be /temp/ $sign in the bracket username underscore home underscore to basically know that it's a home directory with the date. This is year, month, day, hours, minutes, and seconds. All right. So that's the option for like printing the year followed by month followed by day. This will be like 2023-505-02 underscore something like hour, minute, second. .tar.gzip. So that's the output file. I can do the tar command. This would basically take my input location, which is /home/user, combine everything into one single file, -c here. Oh, my bad. This options will compress dash C will basically use the gzip algorithm to compress your file together into one single file, which is .tar.gzip. And then that's it. After you run this command, in the temp folder, there'll be a zip file created. You can replace the tar command with the zip command. You can do zip output input as well, that works. But in that case, you have to change this part to .zip. That works the same way. That works the same way. All right. So you can use this trick to do many, many things on your computer. Remember again, shebang. All right. And we'll talk a little bit more about the syntax in a bit. Okay. This is one example already. I just want to now show the syntax. All right. So you've seen how I use variable. There are also special variable like $pound. $pound will print the total number of arguments when you run a script. When you run a script, for example, I can run like /my script with some option like A, B, C. These become the arguments into your script. So $pound in this case will print 4 because there are 4 arguments. The first argument is /my script. The second argument is letter A. The third argument is letter B, and the fourth argument is letter C. $0 represents the first argument, which is the name of your script. $123, basically $n, where n is the number, would refer to the next input on the command you type in. So basically, this is $0, this is $1, this is $2, this is $3. Why are these useful? This is useful in case you want to write a script and then the user can type in options that you want to tie that to. I can then basically use this to make sure the user can have some input into what they want. And then you can have the script that process everything based on the input from the user as well. $store and $@ are the same. Basically, print the whole thing. My script ABC. That's like the whole line. If you want a quotation around it, basically, let's say instead of just literal string, you want quotation around that as well. You can put quotation around it. You add the quote to the command line. $? Is not about the current script. It's about what happened to the last program that exits. This can be useful when you write a script that checks the status of what happened earlier in the program you run. You can maybe write a script to debug what happened earlier. Check the last program that exits.
Does this one get confused with the single character?
What do you mean?
The question mark. There was one earlier we learned about the question mark in hashtag. The one which represents like how many letters are there.
Oh no, that's a totally different thing. So it will know what happened here. So the key thing is this guy, the $sign. Every time shell see $sign, whatever comes afterward, it would treat that as a variable. So whenever you have the $sign, whatever comes after, that's a variable. So it can be a variable name or this special variable. So it knows exactly what you're referring to. Now you see quote already, and this is going to be the one of the topic that will confuse you guys. And to be honest, I would Google this whenever I need them because, well, I don't want to memorize this. But if I don't quote anything, you just interpret the command or the text as you would normally type things. It would be as if you're typing that command. All right. A quotation becomes basically when you have a double quotation like this, whatever's inside becomes a string, except when you have this dollar sign. So everything that doesn't have dollar sign attached to that becomes the literal string. Everything with the dollar sign, that becomes the variable, and you evaluate into the value first. Huh? Yes, it's like print, and you put variable inside Python print. Basically, that becomes the value of that variable. This is an annoying part. Single quotation, your dollar sign becomes an actual dollar sign followed by the variable name. It will not evaluate into a value. It won't become a number or a value inside a variable. How many of you now see this and like, when will I actually use this? So you might, most of the time you use the double quotation. Does that make sense, right? I evaluate the variable. Sometimes I can use the single quotation in case, for example, I want to generate some command that I will use later. So I want to just store the dollar sign with the actual thing, which I will use the whole thing later. This can be useful. I can pass this thing into the input to other scripts as well, as like a literal dollar sign, for example, dollar sign path, which allow the next script to take in this dollar sign path. The command inside the quote, the command inside the quotation are executed. The output of the command becomes like the actual output, as if they are assigned to a variable, and then you evaluate. Basically, let's say I write the command who am I, right? It becomes Rashada. I run that command, the output behaves like a value. It also works with conditional statement, but here's the annoying part. If you want to compare number, this format. If you want to compare text, need to use this format. All right, again, that's the annoying part. If you want to compare number dash followed by less than, greater than, equal, not equal, less than or equal, greater or equal. If you want to compare text, for example, if you want to compare GCC version with some number, but in the text format, use the sign, the less than sign, the greater than sign, the equal sign. The second annoying part, look at this. Do you notice how there's a space bar in every single symbol? You open bracket, space, 100, space, dash EQ, space, 50, space. There's a space bar separating all these things. Shell scripting is weird that way because the shell is pretty primitive. So if you put them together without the space, they would think, for example, if I do this, without the space here and without the space here, shell will think that 100 and the bracket is a part of one thing. Rather than I have an open bracket, I have a closed bracket. It becomes like one single thing, 4 letters, open bracket 100, which then it doesn't know what to do with it. All right, so you want to make sure that the space in the middle to separate out each symbol. This will be one of the most annoying part about your homework assignment 1. Don't forget the space, because otherwise when you run and test your command, it will yell at you with different things depending on how you put the spacing. Just something to remember, actually. Here's an example, right? I define num A to be 400, num B to be 200. And then I do if num A dash less than num B, then print 400 is less than 200. Else print 400 is greater than 200. So in this case, you're comparing 400 and 200. And in this case, 400 is greater than, right? So it will echo 400 is greater than 200. So think of it this way, it's almost like a program, right? You can use a variable, you can compare them. Will anyone program using shell script? Hopefully not, right? But let's say you build a lot of programs, you want to run program A followed by program B followed by program C and use the output for program B and things like that. Shell script is a perfect product. It's a perfect tool. It allows you to chain together multiple programs on Linux so that you can type one command and go play games. Wait 5 hours, come back, everything's done. That's why I said these are useful to make yourself like allow you to be lazy. Let's say you have to run program A followed by B followed by C, and based on the output of program A, you might have to do if this then that. Write a script for it. After you have the script, run it once, you can do whatever you want in the meantime. You don't have to wait. Everything will be automated. Huh? Oh yeah, sorry about that. If else. The format is if, then, else, and we don't have the open bracket or close bracket, or like Python, we don't have the tab thing. So we have to end with fi. So if then else fi, or if then fi. Fi is like the end of the if clause. Huh? That's the end of fi. So for example here, if the input is not equal, the number of inputs doesn't equal 1, then print illegal number parameters fi. Or you can do if then else and then fi. Basically that's the structure. For loop, for I in this list, do, done. So it's for, do, done. All right, for condition of looping, do what you want to do in the loop, done means that that's the end of your loop. All right. You can also do a while loop again. While, do, done. Here's the condition. Here's the loop body. Again, same trick, right? While counter is less than 3, do this. So quick question, what does this do? So basically, I think this is the last slide today before we move on to the in-class exercise task 2 from the continuation of in-class exercise 2. What does this do? Again, we have the word count program. And this just count character. So what does this do? For I in cat item.text. So item.text has bash scripting tutorial, right? For I in this, in each loop iteration, I'll get one line. So the first line is bash. The second line is scripting. The third line is tutorial. So for each one of these lines, I pass in dash n echo dash sorry. So dash n will basically echo, but don't print the new line. So let's say, let me show this. So if I do echo hi, right, I have hi with the new line. See how the hi doesn't have a new line afterwards. So that's the difference. I don't print the new line after the echo command. Over here, so it will echo bash without the new line, scripting without the new line, tutorial without the new line. but I'm not actually printing. I type the output. So the letter bash get typed into word count and I count the character. So BASH, that's 4 characters. So the first input to the word count would be 4 as an output. Then I loop again with item.text. I have scripting. Scripting, I think that's 9 characters. So the next input to my word count will be 9, followed by 8. So after I type in this, I'll get 4, 9, 8. That's it. All right. So there are more references. I'm sorry. There are more references on the internet. These are like learnshell.org is a useful source. Our assignment is a useful source of learning scripting. And now let's finish up in class exercise 2 for the remainder of your time. All right. It's like you should be able to do it in like 20 to 30 minutes. So it's about perfect time to stop here. Next week, we'll come back and talk about regular expression and get. Then we will move on to C. We are done with Linux. We are about to move on to C next week. All right. Again, the purpose of this section is to make sure that you can program, you can use Linux. That's it. And then assignment 1 will be about that. Afterward, the rest of the assignment 2, 3, 4, and 5 will be about C assignments. Yes. No, we haven't released it yet. I'll release it sometime this week. It'll be given 2 weeks. All right. Any questions? Otherwise, let's wrap up in class 2. One quick note about in class, these are effort based. You don't have to absolutely make it correct. If you do it, you get full credit. Just submit something. But assignment, those are correctness based. Assignment has to be perfect. All right. You have the ability to test everything on your WSL or Mac OS. So test it, make sure everything runs.
So with like the looping, the terminal, so we have to write all that in one line.
Yeah. You mean this? Or when you use the loop?
So like the way we showed it is here. The way we showed it here. Do we have to write like this or like all in one line, like the picture?
Either one of them works. So over here, you see that the command separator, which is the setting format here. That allows me to separate, split the command into the next command. Yeah, sorry, forgot about that. Like so the semicolon allow you to basically split each command into 3 different, like multiple different things.
Could you show an example in the terminal?
You mean this?
In the terminal.
Sure. All right, so there's 3 lines here, right? I can do 4. And right, I forgot the space. So that's a for loop. To actually do the loop body, you have to do, right? Do what? For each line, we want to echo again. Cut the new line. What's the variable name? I. Because I in test.text, right? So it's $I. And then I pipe into word count -C, right? Okay. Don't forget to finish the loop. Oh, something is wrong. Yeah, so you have to cut the text file out, right? Still not valid. Okay. Okay. My bad. So it's a loop for I. Inside, I want to parameterize, I want to test.text, right? Here, I cat the file into 3 lines. That will become the parameter for my variable I. Over here, I get the first line, I think hello, followed by cat, followed by dog-cat. Again, and as you've seen, right, I still have bugs everywhere. So usually when you do scripting, right, the first time there might be like error and say, hey, this is not valid. What I had earlier, I put the $sign too early because basically I want to assign my value into variable I, and then for that inside the command I want to generate is I want to generate the text file one line at a time. So I do cat and then that file, right? And then when I have the parenthesis with the $sign, each line becomes a variable I assign to I. Right. Any other questions?
So how would you do the other way? It's like in one line, you're separating with the semicolon.
Can you like?
Semicolon. On one of them.
What do you mean by other way? Like, oh, you mean into
Like
multiple
each line,
lines,
like-
right? Sure. Let me copy this over because I don't want to type it again. My script.sh. What? So I want to echo this whole thing into so many typo. All right. So I use single quotation for that, right? Because I want the literal of the whole thing. I'm lazy. I don't want to write that again. You see that now it's all in, right? And let me collapse the back here a little bit. Now I can do this. Organize this a little bit, right?
The indentation matter, right?
What?
The indentation.
Doesn't matter. Then chmod -x my script and then run it. See? I can use a separate line to basically tell that, hey, that's a new campaign. Treat whenever you have a shell script, right? Here I forgot shebang. So by default, to be honest, if you don't have the shebang, it would use your current shell to run the line. But to be a little bit more safer, this would allow you to run and make sure bash. Make sure to use bash to run the command. Oops, sorry, that's Vim. All right. User bin bash. Okay. So turns out it's in this directory. So I need to do that. All right, any other questions? Again, quick thing, don't forget that this white space between things. When you want to parameterize things into a variable, put parentheses around it followed by dollar sign usually helps to make it cleaner. When you want to type something or when you use for loop, don't forget that's done at the end. If, don't forget that's fi at the end. These are typical things that you're likely to forget. If things are in the same line, use semicolon to separate the command. What else? The single quote, double quote can confuses you a little bit. Single quote, you saw that already. Now, let me show you what would happen if I use double quote here. Now see, now I use double quote. So when I do for I inside cat that file, it actually do the cat and print it out. So that's the double quote. Again, look at my command I just did. Instead of single quote, I use double quote and write it into my script too. So let me compare. So this is my script.sh. One quick trick in Vim, you can do Control W, V, split the screen. I can then open my script2.sh, right? See how the input is different because I want to echo my command, but I forgot to use single quote, so I got the content of the file rather than just $sign cat test text.
Also, in the terminal, with the up arrow, it will bring the previous text.
Yeah. So over here, I can do up arrow, right? Up. This will be going through my history of what I typed in. All right. So I guess we also have a few more minutes. So let me show you some trick on Vim. So this is pretty useful when you are on this WSL. That would prevent you from having to modify everything either through some kind of like Notepad or some other editing software. So I can do Vim followed by a file name to open a file with that name. Now, Vim has two modes. When you go in for the first tab, it's a command mode. You can put in the command like save. For example, I can do the colon. Colon will have the prompt at the end that is about to take in your command. W is write. So I can do colon W, write the file. So that's the command mode. To go and edit the text, you either basically you want to go into the insert mode. To go to the insert mode, you capital letter I. Capital letter I, see how down there it said insert. Insert means I can type whatever. This becomes a text editor. And to go out to the command mode again, hit escape. So when you hit escape, now you're in the command mode. Now you can do some tricks. For example, the command to cut is DD will cut the entire line. So I hit DD, this line is cut. P is paste, so I hit P, that line I just cut is paste here. I can highlight using the character V, the command V will allow me to highlight. So let me highlight and cut this part, all right? I highlight and cut this. I can then paste it here. Become cut and paste like usual. So this is the part where it's like, yeah, it's kind of like Word, Microsoft Word. You can text, like you can put in the text, you can put in more, right? So let's say I have this text, it's a big file. Let's say it's a big file. I want to search for a certain thing. I can do slash. The forward slash allow me to search. So I want to search for the letter cat and hit enter. It will show me the first occurrence of that word. And then if I want to go to the next one, I can hit the letter N. It will keep going until the end of the file. So let's say I have multiple instead of the word tab, right? I can do search, and then it will show me two operands of this. When I hit N, it will keep going and rotate through. Fancier thing, I can split the windows as you seen earlier. Control W V. Control W V will split vertically. Then I can use Control W with the arrow sign left and right to move between the left and the right window. Each of them works separately, so you can open a new file. For example, I can do :E. :E allow me to open a separate file. I do :E and tab. Tab will again auto-complete. It will show you all the file I have right now. So let's say I want to open infinite.c. I hit enter. Now I have that code open up on a second window. I can again move back and forth, right? I can save this file separately as the other file. Now I have multiple things. I can also open up another one of these windows as well, right? To exit, I can do :Q to exit the current active window that you're working, like the active tab that you're working on right now. So I do :Q with exit from where I am. Fancier things since you're recording, so I just want to say that you can go watch your recording. I can do replace, right? How many of you use replace in Microsoft Word or like Google Shared Drive? So you can do %S followed by the text you want to search for, followed by the text you want to replace it with. G means I want to replace this everywhere in my file. If I hit enter, everything gets replaced automatically. There's many other tricks that you can use. I would definitely recommend go search Vim cheat sheet, which you have the wrap up of like the command that are common and useful. This is actually really nice editor. If you at some point you will memorize the command. So one more thing that I use a lot is I can modify the configuration. I think it's set spell. This is the configuration right now. I use the default one, but I can change it. Right now I set the flag for spell checker. When I do this and write it in a configuration file, and I open Vim again, test file.text. See how it highlights things that doesn't have a meaning. It has a spell checker that would highlight things that have typo. So you can do this, right? Again, there's many things you can do. You can change the text color based on your choosing. You can change the configuration based on whatever you want. So you want to disable this, it's just to set no spell. This is by default, it will not check spelling because many of your program doesn't have a proper spell like thing, right? It doesn't. There might be typo in many places in your program, like variable name, things like that. Yeah, but that's it for like a super quick cheat sheet on Vim. Many people also use Emacs as well. I'm on the Vim side of things because I use Vim a lot. I don't know Emacs command. There's also NeoVim, which is like a fancier version of Vim that you can use in Linux. So I do recommend you to check this out. It's really easy once you are used to it. That's it for today's lecture. Thank you so much. So